Good morning, everybody. My name's Gina Rosenthal. I'm going to talk about Kubernetes myths in actually 13 minutes, I was told. That's all I have. We'll see if we can do it or not. I'm a product marketing manager at VMware in the vSphere BU. I've worked all over the place in the Federation especially. I used to be a sysadmin. I live in Austin now. I love my dog, Fred. I'm G-Minx, so if you have any, you want to comment, heckle me, whatever, you can do that there. All right, let's get right into it. Myth number one, Kubernetes is magic. Is it really? Let's backtrack. I like giving definitions when I'm starting to talk about things and learning about things. What's Kubernetes? So according to the Kubernetes page, Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services. Okay, that's great. What's a containerized application? Let's go there. So this is a definition from TechTarget. What they say is containerized applications are an OS virtualization method that allows multiple isolated apps to run or services to run on a single host and access the same OS kernel. So it's basically containerized applications are containers usually that make up an application. So instead of having a monolithic, everything's in one software package, you'll have a container that runs the login service, a container that talks to the database, a container for every single piece of it. What's cool about it for developers especially, and for us in the long run, is that if the application needs to be upgraded, you upgrade the piece that's in the one container. So if only the login service needs an upgrade or a tweak, they just fix that and it works with the rest of it and it's good to go. I guess I should stop really quick. How many people here are there any developers in the audience? Okay, good. So is everybody kind of like an IT admin, BI admin? Okay, perfect. So we can talk about the devs openly and it'll be okay. I won't hurt feelings. So containerized, another thing to remember about containerized application is it includes everything it needs to run. So all the files, all the environmental variables and libraries that it needs. And that's because of the properties of how containers work, and we're going to talk about that in just a second too. But because of this, this is really just an application built a little differently in a more modern way that makes it easier to upgrade and improve upon and run. It's still an application. It still generates data. It still is going to need data center hygiene applied to it. So we know how to do that as ops people. We have a lot of experience. We have all the scars from doing this in the past, right? So the big buckets are usually security, backups, disaster recovery, and monitoring. The way that we do those things may change a bit and when we support containerized applications. And the methods that we use may be different and called different things. But it's all data center hygiene. All the stuff we've had to do before is what we're going to have to do going forward to support these types of applications. So myth number two, containers are more secure than VMs. Does anybody think that in this audience? No. And let's have this origin story of containers, right? Let's go through this just real quick. And of course, because I'm word girl, I'm going to do a little vocabulary break. What's a hypervisor? What's a container? The difference is, hypervisors virtualize at that hardware level. So one thing it will do is abstract the machine components and the OS away from the hardware. Abstracts it away, right? Containers virtualize at the OS level. It abstracts the application away from the operating system. So with that basis, let's talk about where they came from. Does anybody remember IBM MVS? Oh my God, 2 people. I don't, I wasn't around. So that was really the beginning of containers. They had a container technology with that. The very beginning from not x86, but from a not mainframe perspective, is chroot. How many of you guys have used chroot? Right? Usually you use chroot to allow someone to log into your box. Lots of times for SFTP, that's how I always used it. You give them a specific place on the file system where they're allowed to be and specific things they're allowed to do. That is the beginning of where the idea of containers came from, was chroot. Right there, when you think about that, you know that it can't be as secure as a VM. It just can't from the where it comes from. So everything since then, they've built onto that idea of isolating things in a file system, a section of the file system, allowing people to have access to that. They just started building things to it. So BSD jails were in 2001. They gave it a little bit more security. You got an IP address that you could reach instead of having to navigate a file system. Then after that, Solaris containers. You remember Solaris containers, right? This is really where containers started. It started segregating the file systems and gave more resource controls to zones. And what the resource controls did was said, okay, you can come in here and you can run these commands in this part of the file system, but I'm only going to give you 25% of my memory, or whatever the controls were. Linux containers, LXC, they were important in the history of this, because this is where the idea of namespaces came from. So you've heard of Kubernetes namespaces. This is where that originated from. And that just gives a little more segregation. And C groups further expanded on the idea of being able to control how much resources were allowed to run in the container, so the container processes didn't overrun the rest of the box. And then let me containerize that for you was Google containers. And this was an open source version versus Solaris or BSD. And this abstracted C group support even more, gave it some QoS, so it added more management features. Docker also came around in 2013, and this is an open source project that helped automate the deployment of apps. So this is where we started thinking, well, okay, if I can put all these different containers together, that's cool to make an app, but I need to make sure the login comes up before the database can, and so it has to come up in a certain way, and be able to add containers as the demand for the application grows. That's how all of this works. It started with Docker with an automation and deployment platform. And of course, Kubernetes is turning into the de facto right now. I just want to point out that it was back in a couple of years ago, it was Docker. And you look at the dates, Docker was 2013, Kubernetes 1 came out in 2015. So this is where everybody's kind of settled right now. So that's something to keep in mind too. All of the container stuff is new. It's such new technology. You're not that far behind if you haven't, really delved into this yet to figure out how am I going to support my developers and my engineers. So Kubernetes, I put 2015 because that's the date of version 1 that was available outside of Google. But this is how Google ran containers, so it was around a little bit more. And we know that the founders now actually work for VMware, which is pretty cool. But having said that, no matter how we deploy these containers, how we automate them, and all of this, it's still going to need some kind of data center hygiene, because the containers are going to sit up here, and even Kubernetes, even being when it gets put into vSphere, it's still going to sit up here. That's going to be this playground for the developers to build like they do in a public cloud. Somebody, even in the public cloud, ties that and nails that down to the ground, and that's what we do as ops. And so that data center hygiene, even if it's in with different tools, even if we call things different, that's what we're going to go with. That's what we're going to need to do. All right, so that leads to the final myth I want to talk about, that Kubernetes is just for devs. All right, so like I just said, we're ops. We manage the applications. We manage that infrastructure. We build the infrastructure for them, and we're responsible for the data that gets generated, because if something goes down and it's not available, who are they going to run to? Us. If the data is missing, who are they going to run to? Us. If there's an intruder that gets in, who are they going to run to? Us. This is why it's important to understand what the containers are, to understand what Kubernetes is, then to figure out how you're going to work that data center hygiene into your operations to support your developers. So it's important to understand it. And with the announcement of Project Pacific and having Kubernetes as a first-class citizen in vSphere, it's actually a pretty cool tool, right? Because now you have a tool to give everything to the devs that they expect in the public cloud. It might be a little interesting. You're going to have to figure out there's a concept of a site engineer or a platform engineer. Have y'all heard of that? Basically, that's the person that manages this entire containerized structure. And before, all they've been able to they've never talked to the IT people at the cloud, because you don't get to. Now they'll have you to talk to, and you can design this and make this platform just how they need it to be. Or maybe you'll turn into the platform engineer or the SRE. And this is the whole thing. It's all great, but you still have to protect everything we have at the same time. You're worried about how are we going to fit this into our current processes, but just put down the scotch. It's all good. Remember, DevOps, they want that agility, and now all of a sudden you have this tool with our discipline, our ITSM discipline that we've all got those scars from. You know how to keep that data center hygiene going. We have this shared heritage. The container the devs ran ahead and built the containers. We now have hardware and systems in place that can support it. We just have to remember that we're all in this together. and it'll be cool. I have to have lots of Momo pictures, that's my thing. So that's all I have. So if you want to connect with me, I blog a couple of different places. Gminx on Twitter is the best, and I'll stick around if you have any questions. The end.